Hello guys, welcome to C Learning with new video. In this video we will learn about PBR policy based routing. I have created this topology. So here we will use a different ISP for different users. Suppose here we use ISP1 for data center. Our data center is running on VLAN 10. So the data center users need the higher bandwidth to go on internet. For data center users we use the high MB ISP, high bandwidth ISP, and for internet users which are running on VLAN 2 we will use this ISP2, which is the smaller bandwidth ISP. So the traffic from data center will go through the ISP1, the upper link, and the traffic from VLAN 20, the internet user, will go through ISP2. So we will configure and we will separate these ISP based on routing policy. So this is called the policy based routing, where we separate the traffic of different user on different link, uplink, and other users on different uplink. So we separate the uplink. So this uh, is the policy based routing. So let's go toward the configuration. So first of all we go here on switch. We will configure switch. We will pass the VLAN here. So first of all we create VLAN batch 10 and 20. So here on interface giga 0/0/1. So this is the interface 001. So here we pass both port link type. Port link type is trunk, and we pass both VLANs port trunk allow pass VLAN 10 and 20. So we go here on interface G002 and 003 and make them access port link type access, and port default VLAN is, so this is the G0, which is the upper, and its VLAN is 10. And on G003 will pass VLAN 20. Sorry, default port link type is access and port default VLAN is 20. So now we go here. We will configure here the IP scheme first, complete the layer 3, and then we run the OSPF protocol. So here I have one link. So you can use here the layer 3 switch as well, and you can create the multiple ISPs. So I am using here router, so I don't have the extra interface. I have only 3 interface. So I will use this interface as a sub interface to for different VLANs. So let's go on interface G000, interface G0/0/0.104 VLAN 10. So .1q termination, VID 10, and then IP address is 192.168.1.1 and 24, and R broadcast enable. And now I go on the sub interface G0/0.20, and I will do the same. IP address is 192.168.2.1. so I have mentioned here, sorry, this is the 20.1, so let me make it 2.1, 1.1 and 2.1, and here is .1q termination and VID for 20, and then R broadcast enable. So you can use a layer 3 switch and create the SVIs. So I am using this way, and then after that you have to configure the uplinks. So here I will give the IP address 10.1.10.2 on G001. So interface giga 0/0/1, and here I will give the IP address as a 10.1.10.2 and 24, and I will go on interface G002, which is this interface facing to ISP2. G00 IP address is a 10.1.20.2 and 24, and then I will configure OSPF here. So I am running OSPF1 area 0, and then network here is a 10.1.10.0/0/0/255, and here also we are running network 20, which is facing downward here. and we are also using network here 192.168.1.0/0/0/255, and also we are using the network 2.0. So these are network we are using here. So let me configure here as well. System view interface giga 0/0/0, IP address is 10.1.10.1 and 24. The this interface is G001, and here IP address is 10.1.50.1, 51 and 24. So let me configure OSPF here. And also we have another network here. Now you can see here the OSPF states are up: init, two-way, X start, and full state. And here as well we are using 50s network, sorry, 10.1.50.0. and let's go here. Let me configure interface giga 0/0/0/0, and IP address is 192.1, sorry, 10.1.10.1.20.1 and 24. And on G001 we have IP address 10.1.60.1 and 24. OSPF 1 area 0, network is 10.1.20.0/0/0/255, and here we have another network which is the 60s. Network display current configuration, so here we are using two networks 60.1 and so let's go here. System view interface giga 0/0/0, IP address is 10.1.50.2 and 24. The bellow interface is G001, and the IP address here is 10.1.60.2 and 24. So after some times their neighbor will be up when we configure. Let's configure loopback interface for the temporary Google ping, sorry, 0. IP address here is 8.8.8.8 and 32. Let's configure OSPF. Networks are 10.1.50.0 0/0/0/255. Also we have 60 here, and then we have network is 8.8 and 0/0/0/0. So we configure here the networks. So it's the normal network. Now we can ping this network 192.168 1.255.255.255 192.168 1.1 is the gateway for that. Let's ping Google 8.8.8.8. So yes, reachable from here to here, it's reachable. It will take one of the two paths, any path randomly to go on this loopback interface, but we will manage it by adding policies that we will configure that data center user will go through ISP1, strictly through ISP1. So here is 2.10 and 255.255.255.0 and 192.168 2.1 is the gateway. Ping 8.8.8.8. So let's trace the route. So from which path they are going, trace rt 8.8.8.8. So it's taking the 10.1, which is this interface. This PC VLAN 20 PC2 is going from the ISP1, and let's check this one, trace rt 8.8.8.8. so it's taking this one, ISP2. So we will restrict that the VLAN 10 and the data center user data should go through ISP1, and internet users data will go through ISP1. So for this we will do the PBR here, the policy based routing configuration. So let's go toward the policy based routing configuration. First of all, we create an ACLs for these two, VLAN 10 and VLAN 20. So let's create an ACL 3000, and here we'll go rule permit IP source 192.168.1.0 0/0/0/255, and here as well we'll configure 301, and this is the network is 2.0's network. So I have configured ACLs. Now I will go toward the PBR configuration. So the first step to configure PBR is you have to configure the classifiers. So you have a command traffic classifiers question marks. So you have to name the classifier. You can choose any name. So I'm using here the C1 classifier, and then operator we use the for the matching rules, that the matching condition should be and or. And means the one statement should be right, and it will go to follow that rule, but or means the both condition should be right. So that's why, so we will use or here. Rule of the matching one of the statements, only one statement should be matching all statements. So you can see and for all statements. So I have created C1 rules. Here I will use if match ACL 3000. So here if match 3000, then it will go to permit. So let's back. Now we create another classifier name C2. Here we will run the command if match ACL 3001. So we have configured two classifier one for VLAN 10 and one for VLAN 20. One for VLAN 10 network 10.1.1, and other one for 2.1 network. In ACLs you can check. So ACL 3000 is 1.0 and ACL 3001 is 2.0. So we create two classifiers. Classifier C1, here we match ACL 3000, and classifier C2, here we match 3001. And now the next step is we will configure the behavior. That in behavior we will redirect the traffic of ACL 3001 to ISP1. So in behavior we will define the next hop that redirect classifier C1 network which contain ACL 3000 and redirect that traffic to this next hop. So here we will configure traffic behavior. The name of traffic behavior I'm taking here B1, and then here you will run the command redirect IP next hop, and here you will define the next hop of the ISP, which ISP you want to redirect this traffic. So I am using ISP1 for this. So next hop of ISP1 is 10.10.10.1. So I will use the classifier B2 and use here the same redirect this class behavior traffic to 10.1.20.1. so which is this ISP2 20.1. Here we will match this behavior and classifier. in traffic policy P1, you can name any, you can write any name, so I am writing P1, and then here I will merge these classifier and behavior. So use classifier C1 which contain ACL 3000 and use behavior B1. The classifier C1 contain ACL 3000 which contain this network, and behavior contain this next hop, and I have defined here the use classifier 1 which means that this network, and behavior 1 means this next hop, and use this network on this next hop. So when we apply this traffic policy on this interface, it will going to work. And also we will define classifier 2 B2 C2. C2, in classifier C2 we define this network VLAN 20's network which contain ACL 3001, and behavior B2 we define this ISP2 next hop. You can see here in behavior 2 we define this next hop which is the ISP2 next hop, and I have run. So our traffic policy is ready. Just go on the interface and then run this command there. So I will go, we have two interfaces, sub interfaces will go respectively on both sub interfaces. So display this, you can see here. So I will run this command here, that use traffic policy P1 on inbound direction, mean inbound direction check via this policy, and also will go on .20 and run this same use traffic policy P1 on inbound direction on both sub interfaces. And now if we trace this route on from here VLAN 20 PC2, previously PC2 was taking above path, this path. Now we have configured that PC2, the VLAN 20 will use this ISP2. So let's check now. Let me check here. Now you can see here, previously it was taking this next hop which is the next hop of ISP1. Now after the PBR policy based routing, we strict this, that this PC2 will take the ISP2 next hop, so it's take the ISP2 next hop. Now you can see here 20.1 is this next hop, and let's check 10.1 trace route. Previously it was taking 20.1 which is the ISP2 next hop, but we strict that VLAN data center user should take the ISP1 next hop and use the next hop this. So it's taking this 10.1. Now you can see here ISP, if we add here more PCs, we just define the we'll go here in interface, system view interface giga 0/0/9, and port link type is access, and port default VLAN should be 10, and here we will give IP 192.168.1.20 255.255.255 and 192.168.1.1 is the next hop. Let's trace this loopback, trace RT 8.8.8. After some time it will go on internet via this route, ISP1 route. Let ping first, ping 8.8.8.8. yes, it's reachable. Let's trace now. So it's taking 10.1 which is the ISP1 next hop, ISP1 route. So VLAN data center traffic is going from the ISP1, and other VLAN 20 internet user is going through ISP2. So this is how policy based routing work. We transmit same type of traffic from the different bandwidth and the other type of traffic from the different uplinks. So this is why we use the policy based routing. So this was the simple topology. Hope you like the video. If you have any comment or the question, so you can ask in comments. So hope you like the video. Thank you very much.